In today's lecture, we'll be discussing about the ECG's machine. Before I start my lecture about the ECG machine, I want to tell you something about the first lecture of the first class. A very small part of this lecture has got some relationship with this lecture. In the first lecture, I told you ECG is one of the most widely used and useful investigation in contemporary medicine. And ECG provide valuable information about the different cardiac problems, particularly about the arrhythmias. So ECG is one of the oldest, simplest, cheapest, easily portable electromedical instrument which provide immediately a lot of information about the cardiac problems, particularly about the arrhythmia. This was, in addition to this matter that we discussed, we have discussed three terms. One was a definition of the ECG. The second was definition of electrocardiograph. The third one, the ECG graph. Definition of the electrocardiogram. Recording of electrical activity over the ECG paper is called electrocardiogram. And those devices which are used for recording of electrical activity is called electrocardiography. Those devices which are used for recording of the electrical activity of the heart is called electrocardiograph. This ECG machine is electrocardiograph. And the third one was the ECG graph. ECG graph is defined as a series of the waves and reflection which are seen during one cardiac cycle. Now I come back to this lecture, ECG machine. What is the ECG machine? ECG machine is a standard electromedical instrument. ECG machine is a standard electromedical instrument which records the electrical activity of the heart by drawing a trace over a moving paper. This moving paper is called ECG paper. ECG paper is a standard graphic paper which is made from large square as well as small squares. Later on I will have a detailed discussion about the ECG paper. So again we come to the ECG definition or ECG machine. ECG machine is a standard electromedical instrument which records the electrical activity of the heart by drawing a trace over a moving paper. This moving paper is a standard graphic paper which is called ECG paper. ECG paper, as I mentioned, this is a standard electromedical instrument. The standardization of the ECG machine is characterized by two things. Number one is constant rate or constant speed. What does it mean, constant rate or constant speed? It means 300 large squares of ECG paper moves under the stylus or needle of the ECG machine within 60 seconds or 1 minute. So 60 seconds is equal to 300 large squares and 300 large squares equal to 60 seconds or vice versa. Or in other words, 5 large square which represent 25 millimeter moves under the stylus of the ECG machine within 1 second. Or in other words, 1 large square moves under the stylus of the ECG machine within 0.2 seconds. Or even a small square move under the stylus of the ECG machine between the 0.2 to 0.4 seconds. Then we will discuss about those mechanisms by which these numbers are produced. So standardization of the ECG machine is characterized by two things. Number one is constant rate or constant speed. What does it mean, constant rate? 300 large squares or large boxes of the ECG paper when moved under the stylus or needle of the ECG machine within 60 seconds. This representation of the constant speed. Or in other words, 5. In some book just mentioned 5 large squares. When moved under the needle of the ECG machine, it takes a time of 1 second. 5 large square, 1 second. 1 large square, 0.2 second. 1 small square, 0.04 second. This was the first thing which represents standardization of the ECG machine. The second thing that we should discuss about the standardization of the ECG machine is calibration of the ECG machine. What is calibration of the ECG machine? There is a sign of 1 millivolt over this ECG machine. Calibration of the ECG machine is defined as a standard signal of 1 millivolt. As a standard signal of 1 millivolt moves or displaces the needle or stylus of the ECG machine up to 10 millimeters, or up to 2 large squares, or up to 1 centimeter, or the electrical voltage which is equal to this one, 1 millivolt. So what is the calibration of the ECG machine? Calibration of the ECG machine is a standard signal of 1 millivolt which displaces or which moves the stylus or needle of the ECG machine vertically up to 1 centimeter. This 1 centimeter represents 10 millimeter. This 10 millimeter represents 2 large squares, and this 2 large square represent 1 millivolt. So the standardization of the ECG machine is very useful for the height of the wave. For example, if we have got not P wave, it represents pulmonary hypertension. If the QRS complex is large or the height is larger than the normal, then the 2 large squares, it represents hypertrophy. And another T, if the T is high, we think about the hyperkalemia. So this calibration signal is very important for standardization of the ECG machine. There is a mark over there which is represent 1 millivolt. Before we take ECG, we should adjust this ECG machine by 1 millivolt. This 1 millivolt is a standard electrical voltage which is produced by heart, especially left ventricle play a major role in the production of this 1 millivoltage. Standardization of the ECG machine is characterized by two things: constant rate or constant speed, and the second, calibration. When we want to talk about the calibration, you should not forget a term of standard signal of 1 millivolt, which displays stylus of the ECG machine vertically 10 millimeter or 1 centimeter, 2 large squares, or 1 millivolt. This was about the standardization of the ECG machine. Now we will come to the 4 major parts of the ECG machine. This ECG machine is made mainly from 4 parts. The first important part is electrode. The ECG machine have got 10 electrodes and they produce 10 leads. 4 of them is called limb electrodes and 6 other is called chest electrode. What is the electrode? We have discussed this matter in a previous lecture. Electrode means conductor through which electrical impulse leaves or enters to an object, substance, region. This is called electrode, or a simple word, electrode is a device which collects the electrical impulse and then emits the electrical impulse. So we have got 10 electrodes. One of the most important part of the ECG machine is 4 major part of the ECG machine. First, electrode. We have got 10 electrodes. 4 of them is called standard limb electrode and 4 other is called chest electrode. This electrode should be applied to the special part of the body which is labeled this electrode for that part. For example, we have got RA, right arm electrode. We should apply to the right arm. And then left LA electrode or left arm electrode, or RL, right leg electrode, or LL, left leg electrode. It means we should apply these 4 standard limb electrodes according to those places which are specified for touch or connection of these electrodes to this part of the body. This was about the electrode. Our important part of the ECG machine is electrode. The second part, motor. This motor is also fitted in this ECG machine. And what does do this motor? Remember, there are 2 types of electricity come to the ECG machine. One is come from systemic or general power. This systemic or general power goes through the motor, and this general power moves the motor moves the paper, and paper moves under the stylus of the ECG machine. This electricity which comes from systemic electricity or general electricity should not be confused about this ECG, about the cardiac electrical force. There are 2 types of electrical force come to the ECG machine. One is general power, the second cardiac electrical force. The general power go to the motor and the cardiac electrical power go to the needles and lead to deflection of the needle of the ECG machine. And when the needle of the ECG machine heated by this electrical impulse, this needle of ECG machine moves over the ECG paper and produce trace of the ECG paper. First electrode, the second motor. Motor moves the Then the ECG paper moves under the needle of the ECG machine, and stylus, heated stylus, moves over the thermosensitive ECG paper and produce a trace. This is the mechanism of the trace motor. The second one, needle or stylus of ECG machine. One cardiac power comes to the motor of the ECG machine, and another power comes to the needle of the ECG machine. When the needle of the ECG machine is detect this electrical impulse, the needle gets warm, or the needle is heated. Then this heated stylus of this ECG machine moves over the ECG paper and produces trace and wave segment and interval. This was about the motor and needle or stylus of the ECG machine. Remember, ECG paper is a thermosensitive paper. What does it mean, thermosensitive paper? Why I discuss this part? When the electrical impulse, cardiac electrical pulse, come to the needle of the ECG machine, the needle of the ECG machine is heated.
Warming.
Is heated. When this needle is heated, this tip of the heated style moves over thermosensitive paper, and they produce this trace. The ECG paper is stripped, and this trace, the mechanism of trace is warming up of the needle of the ECG machine, which move over thermosensitive paper and produce the trace. Did you understand the mechanism by which trace is produced? Thermosensitive paper of the ECG machine. Power, we told you there are two types of power coming to the ECG machine. One is a general power, another is cardiac electrical power. Cardiac electrical power is related to the needle, and general systemic power is related to the motor of the ECG machine. Another. So we discussed about definition of the ECG machine, standardization of the ECG machine, constant rate or speed of the ECG machine, calibration of the ECG machine, four major parts of the ECG machine: electrode, motor, needle, and thermosensitive ECG paper. ECG paper, these are four major parts of the ECG. We also talk about those power which come to the ECG machine. And finally, when we want to record the ECG machine, about the calibration, I want to repeat again the calibration as a standard signal of 1 millivolt. Displays vertically the needle of the ECG machine up to 2 large square. This 2 large square is equal to 10 millimeter, or this 2 large square represent 1 centimeter, and this 2 large square represent 1 millivolt. For example, if you want to take ECG, every ECG should be adjusted according to the calibration signal. Calibration signal should be included in each recording of the ECG. When you want to take the ECG of Gulab, you should change this 1 millivolt. When another ECG, every ECG should adjust the calibration signal. For example, in this case, this calibration signal, the shape may reach to 1 large square. This is the rank. 1 large square is representation of 0.5 millivolt, or 0.5 centimeter, or 5 millimeter. This is wrong. And this one reached to 3 large square. This is also wrong. But this is a standard calibration because it involves 2 large squares. And this is a calibration examples. So we discuss constant calibration, 4 major parts of the ECG. One was electrode, motor. We have discussed about the electrode in previous lecture. Motor, needle, thermosensitive. Do you understand about the thermosensitive paper? What is the sense of the thermosensitive paper?
ماشین که هست رنگ نداره. فقط به طور مثال کاغذ از یک هست حساس به مقابل حرارت.
ترموسنسیتیو.
جریان‌های برقی که به سطح سینه قلب به طور مثال به وایرها انتقال می‌کنه، وایر به الکترود انتقال می‌کنه، از الکترود به وایر، از وایر به استرس ماشین. این داغ می‌سازه. بله داغ ساز می‌کنه. استرس داغ در روی ماشین در روی کاغذ ترموسنسیتیو که حرکت کرد تریس است.
یه تریس میگه. خود ECG paper and strip paper. This is the trace. Now power and also When making recording of the ECG, before we take the ECG, what cautions is necessary to the patient should be respect to that, or we should do that. Number one, we ask the patient to lie down, and we ask them to be relaxed. What is the reason? Because the skeletal muscle, the tremor, may be concomitantly with the electrical cardiac impulse recorded. So you ask the patient to lie down, and he should be relaxed to prevent skeletal muscle tremors. The second, all those electrodes should be placed in their own places. I told you, it is not necessary to remember which electrodes are involved and which leads. It is important to connect these electrodes in special places, or especially those labeled according to their label. You should connect the electrodes, limb electrodes. RA electrode should be applied to the right arm, and left electrode should be applied to the left arm. RL should be applied to the right leg, and LL should be applied to the left leg. The second thing, the third thing that you should care during the taking of the ECG machine, taking of the ECG, calibration of the ECG. We should adjust a standard signal of 1 millivolt. Displace the needle of the ECG machine vertically up to 1 centimeter. So for each lead, 3 or 4 complexes are sufficient. For example, lead 1, when you want to record the lead 1, for the lead 1 you should take 3 or 4 complexes. Did you understand the meaning of that? For example, lead 1. For lead 1, we have got for example, lead 1. This is 1 QRS complex. This is second QRS complex. This is 3 QRS complex. When you want to record the ECG of the patient, at least 3 complexes should be taken for the lead 1. 3 to 4 complexes is sufficient for each lead. Understand?
Yes.
Another, let me discuss about the ECG paper. What is the ECG paper? The ECG paper is a thermosensitive paper which moves under the needle of the ECG machine, especially 300 large square of this ECG paper move under the needle of the ECG machine within the 60 seconds. Within 60 seconds. Or in other words, 5 large square, which represent 20 millimeter, should pass under the needle of the ECG machine within 1 second. 1 large square pass under the needle of the ECG machine within 0.2 seconds. Finally, 0.04 seconds. This 0.04 second represents duration of the small box, which moves under the stylus of the ECG machine. How much time should be taken? It should take 0.4 seconds. Remember, I discussed this matter, but the basic building unit of the ECG paper is the small squares. The basic building unit of the ECG paper is the small squares. All of measurement that we do during the interpretation of the ECG, we should use 0.04 second. Right now we will discuss those mechanisms by which these numbers are produced. Since I mentioned before, 300 large square moves under the needle of the ECG machine within 60 seconds. Within 60 seconds, 1 large box. How much time is taken when passed under the needle of the ECG machine? We don't know about this number. We'll give the number of the X. 300 large square moves over the 60 seconds. 1 large box, the duration of 1 large box is unknown. This is X. 5 small, 300 in 60 seconds. 1 is X. 60 over 300. 60 over 300. 60 over 300. 0, 0, 6, 5 times go to 60, 1, 5 times. 1 over 5 equal to 0.2 seconds. This was the mechanism of 0.2 seconds. Right now we will discuss about the mechanism of the 0.04 seconds. Since we know one large square consists of 5 small squares, or one large square consists of or include of 5 small squares. So 5 small square equal to 1 large square. 1 large square equal to 5 small square. We know the cost of the 1 large square. 1 large square 0.2 seconds. So when 1 large square duration was 0.2 seconds, this large square also included 5 small square. So 5 small square is also equal to small square 0 x 5 small square equal to 0.2 seconds. 1 small square is
X.
x equals 5 in the denominator and 0.2 in the. Then there is one pointer. 2 over 50. 2 divided by 50. 2 is less, 5 is more. Pointer 0. Still 2 is less. But there is another 0. And 4 times goes to 200. This is the mechanism of 0.04 seconds. So this is, suppose this is the ECG paper, and this is a large square, and among of this large square you see small square. This is the horizontal line. The horizontal line of the ECG paper represents time and duration. Time and duration of the wave segment interval should be used from horizontal lines. The vertical line provides information about the height of the waves. For example, normally P wave have got 2.5 millimeter. In cases of pulmonary hypertension, it becomes more than. So this vertical line should be used for height of the P wave, height of the QRS complex, height of the T wave. For example, in pulmonary hypertension, the P height is increased. In cases of hypertrophy, the peak of the QRS complex is increased, and in the case of hyperkalemia, the peak of the T is also used. So the vertical line is used for the height of the wave, and horizontal line is used for the time and duration of the wave. So as I mentioned before, this ECG paper is thermosensitive wave. This is the stress bar. Stress. This is the trace. This is the trace. And this trace, and when we combine the complex with them, make it the ECG graph. What else remained?
That was
No, that was. Ali, tell me something about this lecture. What did you catch from this lecture?
I came late, but I found
I
something
was
about.
not present in here. I want to describe this issue.
enough, sir. Enough.
Enough.
Yeah.
Thank you for listening to this. Now, this is your turn. Whatever you catch from this lecture, you should tell me about this lecture. Hakim? Oh, sir, that's this guy. Whatever you know, you